Hi everyone, this is weekly contest 550. Nearest available drone, 2D, X, Y, and travel. This is the target. Okay. Okay, so basically, just order range. Okay, that's fine. Uh, more than equal to V2. Okay. Just return index. 1, 1, -1. Okay. Minimize maximum. Integer period and integer array lights. So lights is duration of the green phase of the live traffic light. At time 0, every traffic light starts at the beginning of its green phase. Their phases are synchronized. Every traffic light starts a new cycle at the same time. And every cycle lasts exactly a period of seconds. Therefore, the red phase, okay. The red phase will last for period minus light's 5 seconds. Arrival time of the Jave car, 1 traffic light. Okay. Uh, can you do, you can't do n squared. Let's see. Arrival time 0 to traffic light with lights 1 equals to 3. Here, so this waiting time is 0. 1 with let 0 equals 2. Here, so it's 5 squared 2. Mean time is 3. Okay. Okay, so uh this is easy, I think. You mod 8. If it's greater, you just take the lower bound, otherwise you take the other one. Oh, overflow. Lower bound all lights and X. If it's the highest, right? Okay, so Rev, Rev upper bound. How did I get 2? It's the max, so let's see. 8, I got a mod, so here 5. So 5 has to be paired with this. 5 greater than 2, the waiting time is 8 minus 5 is equal to 3. And then for 11, it's 3. Since 3 is greater than or equal to 2, the waiting time is 8 minus 3 equals 5. I don't think I understand this. Okay, well that passed, so. Maximum gap between stations. Given two strings skill and station of lengths n and m, skill I is the skill of worker I, and station j represents the skill supported by station j. So you must assign every worker to a distinct station. So permutations. Let j be the index of the station assigned to worker I. So station j I must be equal to skill I, and then they must be strictly increasing. Station and skill, okay. The gap is the maximum difference. So one worker gap is 0. Assign them to station 0, 3, get a gap of 3. And they must be strictly increasing in worker order. You want the maximum difference, okay. C, B, C, X, Y, Z. C, X, Y, K. Okay, so X, Y. I think you can just try a greedy solution. While I smarted them. If j equals n minus 2, you break. Actually, we don't even need, don't even need I. If skill j equals station I, j plus plus. Answer equals max answer, I minus 3 equals 0, and pre equals I. Otherwise, right, if it's not equal, you just increment I, so we don't do anything. So we have our answer, and we're going to return our answer. Okay. I want to see if this is correct. So 0, we shouldn't get 0, we should get 1, right? Yeah, we should get 1. So it's I minus I plus pre, I think. So I minus pre plus 1. Oh, we still don't get that. We're at n minus 1, we break. 1, 2, should it be 2? XY should be 1, because we don't want Z. Oh wait, this distance 1 and this distance, we don't have 1. I wouldn't need to add 1. But how do we get 0? Oh yeah, because we're not adding anything. So this is 1 and this is 1. CBC, okay, so this is right. So now you just gotta iterate. It's equal to skill and minus 1. We can break, well, we gotta update our answer. Answer equals max answer, I minus pre. 4, 2, 3. Is there any corner cases? Would this greedy always work? I think so. This greedy would always work. No, okay. F, A, F, G. I'll put 1. Because okay, because over here we didn't change it. Three should be equal to I over here. J is 0, pre is I. Okay. 4, 2, 3. Is that right? Let's see. A, C. So let's see. 1, 2, 3, 4. What would be a better? Right? A, C would be better. Okay. I'm not really sure. So this one, what would we do? We do AA and then AC. Oh, wait. I think I know. So you have a prefix and you have a suffix. Okay. Graph is less than n, and else, and skill I, skill pref I is equal to station I, pref I plus plus, for int I equals m minus 1, I greater than 0, I minus minus, if I plus 1 is less than m, suff I is equal to suff I plus 1, if suff I less than, suff I is greater than 0, greater than or equal to 0, and skill suff I is equal to station I, suff I minus minus. Okay, then we can use 2 pointers. Oh, I don't need I, so while I is less than j. Okay, so for int I, while j is greater than or equal to 0, and suff j plus ref I is less than n. Right, we need n over here. J minus minus. J minus minus. If, well, we can just do answer equals max. Answer I, j minus y. Return answer. Then I get 0. J minus I, 0, 3. 3 minus 1 is 3. Basically, none of them work for some reason. F I and suff j, so that part is correct. Ref I is less than n, and skill phi equals station I. So 0 equals station 0, so pref I plus plus. Okay, so this is correct, I think. So phi minus minus, yep. Oh, so phi plus plus. 3, -1, 4, 1, -1, and 3. Okay. X, Y, Z. Z, Y, X. 0 and 3. 1 and -1. Yeah. 0 and -1. This part is wrong. 1, 2, 3, 3, 0, 0, 0, 1. Oh, you gotta count from the back. Of course, this. Oh, 5. 5 plus 1. -1. Alright, so we can increment p or we can decrease that. Two, 2. 3 is 4. This should be n minus 1. -1. So right here we should be at 0. And we should be at 1. So it should be -1. It shouldn't be 1. Okay. 5. Is 5 correct? 5 is correct. We can just add a check over here. If n equals 1, return 0. Still failed on some. VA. Use test case. 1, 2, 2, 2. -1, 0, 1, 1. 2 and 1 over here. Okay. 4 expected 3. Something weird. Oh, now it works. Alright, okay. Just keep going. Elevator request 3. Given an integer n denoting the number of floors in a building where the floors are numbered from 0 to n minus 1. You are also given an integer start and a 2D array request, where request I equals arrival floor. Request for floor is made at time arrival. At time 0, the elevator is at floor start. At each second, the elevator may move up by 1 floor, move down by 1 floor, or remain at its current floor. A request can be fulfilled only at or after its arrival time. It is fulfilled instantly when the elevator is on its requested floor at any time from its arrival time onward. Return the minimum time needed to fulfill all requests. What's this? We going to do time 6, time 9. All requests are fulfilled in time 9. Oh, so you have some requests I need to fill. Okay. This one has already passed. It's fulfilled. Okay. Quest.length less than or equal to 16. That's weird. You can use. Could you use DP? I think you can. Current floor and your mask. Oh, why is this at floor N? Oh yeah, because there's N floor. Floor of detention. Well, you always come from some floor to another. So you can just put M over here, right? It'll be one of them. So you can try to come from anything. Let's swap this a bit. think this is more intuitive. BP1I, and now we're at floor I. Right, this should be equal to, so start, and then you get there. Okay, now I can just use bit mask. And then you need a submask. I forgot to do this. Let me go check the signal guide. Point to 42 equals 0, 42 is less than m, 42 plus plus, if subset 1 over 42. If this is true, and we come from floor 1 to floor 2. So we have ink. Yeah. Wait, so floor 2 comes to floor 1, right? Yeah. Well, first we gotta see if the time matters. No, does it matter? I don't think it really does, right? Yeah. So int time. The time we get there would be, so first it would have to be max requests. Floor 1, 0. Yep, floor 1, 0. And what's else, right? So BP subset floor 2 plus what? Plus the time needed to go. ABS requests floor 2, 1. Minus requests floor 1, 1. dp mass for 1 equals min dp mass for 1 time. Return min element all dp back. 6. You go from 0 to floor 6 for 6, and then you go 2 more. 0 to floor 5, and you wait until 6, and you go 2 more. So it should be 9. BS start minus request I0. Start request I0. 6. So to query, we need 6. So that part is correct. So from 6 to 8, we did something wrong. From 5 to 8. Okay. 3, 1, 2, subset is 2, 1. Oh, F2 can't be equal to F1. So 6. 2 to the 16 times 16 times 16. Okay, this is fine. So again, just some blocks, don't need to fix. 7 came from 1. Okay. Oh, F2 is okay. If built in up count. Or subset equals submask equal to this. So subset is something like that, and this is submask. So F1 submask something from subset. Okay, so alright, nice. Got too many wrong answers on number 3. Way too many. Yeah, people will catch up. It's fine. I did Q4 pretty quick, actually. I like that. All right, so I'll go over solutions and I'll post them. Um, so Q1 is an implementation problem. So the problem is you have 2D integer array drones. You have the X, the Y, and the range of it. And you have a array target. So the coordinates of the target you're trying to get to. So for every drone, right, you can move range for Manhattan distance. So you can move some value in the X, some value in the Y, and the absolute values of the sum should be less than or equal to the range. And you just want to see if they can reach target. And if they can, you want to find the drone with the minimum index, uh, with the minimum distance that has to travel and the minimum index. So just in implementation problem, you go through every single drone. You have your distance, right? This is Manhattan distance. So first condition is this has to be less than or equal to V2. It has to be less than or equal to this range, or else it can't even get to target. And then if this is less than our answer, then answer equals this, and our index is I, right? Because in the end, I have to return an index. And then every time I use I plus plus, and then I just return your index. So yeah, pretty simple implementation problem. Okay. Um, next one. So Q2. Okay. So this problem is worded kind of weird, but if you understand, it's pretty easy. So I'll just explain details more. So you have some times that your car arrives, right? You don't even need. So you have some time, sometimes you have these lights, and you have the period of time. So, for example, when this thing at time 2 arrives, right? You can give it with this light at 3. So what this light means is between 0 and 3 is okay for you to go there. So 2 can be paired with 3, and then we have 0 time to wait for a red light, right? There's no time you have to wait for a red light. For 5, you can't do anything. You can pair it with the 3, for example. And then you have to wait 3 seconds before it can go to a green light. Because after 3 seconds, it's the end of the period, and you can, all of these are green lights. Um, for 8, that's the end of the period, right? So basically, you can pair it with, for example, 2 or 3, both of them will work, and you have 0 wait time. And for 11, you mod 8 is 3. So as at the third point, and you can pair with this 3 because it's equal. So you can, for example, pair it with this 2, and then you have to wait 8 minus 3 equals 5 seconds before it turns near green light. So basically, pretty simple, I think, right? You go over all of the times, you mod from the period. If x is less than the max value in those lights, you can continue. Because you can just choose that light and then you'll be fine. You have 0 wait time. Otherwise, no matter what, it has to be at least period minus x. So answer equals max. Answer period minus x. In the end, you return answer. Yeah. Okay. Q3. I don't really like Q3 because I got too many wrong answers on it. I'm gonna get again. I got 4 wrong answers on this problem, which is really bad. Anyways, let's start. So let's see what this problem is again. Okay. So you have skills, right? You have skill workers for skills, and you have a bunch of stations. So basically, you're trying to pair these with something over here, and this with something over here, and you want to find the maximum distance you can get, right? For example, for CBC, you can put C over here, and then you can put B over here, and you can put C over here. And you'll get a distance of, for these two, you get a distance of 1, 2, 3, and 4. Right? You just want to find the maximum distance. So you use a prefix and a suffix array to count the number that are possible. So what the prefix array stores, so ref I, stores, stores number of workers from the prefix that you can fit. Right, we're trying to find, how do I explain it? Let's see. We're trying to find 2 points for pref and stuff that satisfy all of the skills. So let me continue with stuff really quick. So stuff I stores number of workers from the suffix that you can fit. Not really the number, the next worker from the suffix stores the next worker that you can fit from one prefix. Right, so what does this mean? For example, if pref of 1 equals 2, right? So over here, let's see, where is it? Right here. Right, pref of 0 over here would be 1, because the next worker you have to look is worker 1. Over here, the next worker you have to look is worker 2, so pref of 1 is 2. And over here, pref of 2 is 3, because you don't have to look at any workers. And it will be 3 from now on. And then suffix is the same thing except from the suffix. So you first look at this one and this one. So over here, it will be 1, right? The next worker you have to look at is 1. Over here, the next worker you have to look at is 0. And then from here, it's still 0. And from here, it will become -1 because there's no more workers you have to look. So you create these pref and stuff and you fill them in using kind of a 2 pointers, but not really. More like a prefix, but not really sum. Right? So you just iterate over all of the stations. If I is greater than 1, you can just pref I goes pref I minus 1. Right? From the previous one, you can always fit over here. And then you check if the current skill is equal to the station. If so, you can increment your pref, right? You can look at the next worker from now on. Same goes with stuff, right? It's just reversed. And then once you manage to do those, you can see, right? For pref, for example, you can choose these two and a C over here, and they would fit CBC. It would be the same thing as skills. So what you're looking for is for pref of I to be stuff of J plus 1. All right, over here, you see the next one is 2, and over here, the next one is 1, right? You can see 2 is 1 plus 1. So you're trying to find 2 indices such that pref I goes to stuff I plus 1, and the difference is max, right? So you can just use a map from now on, right over here. For range I is equal to n minus 1, I is greater than or equal to 0, I minus minus. If pref I is not equal to 0 and pref I is not equal to pref I is not equal to n and pref I not equal to 0, then MP pref I minus 1 is equal to I. So what does this part mean? Well, what this part means is if um for example over let's say we don't have another z, we don't have x, y, z. Actually that isn't very good example. Let's see. Okay, yeah, fine. So if it's x, y, z, a, right? Then you see x, y, z works, but we're not going to count 3 and 0, 3 and -1, right? If x, y, z is over here, and once we get to z, we see pref is equal to 3, and we see stuff is equal to 2. But we don't count that, right? Because it's continuous. It's not from pref and stuff. And over here, if n equals 1, return 0. So there's no more edge cases I have to consider. So you do that. And then for int I is 0, I smaller than n, I plus plus. Now you look at stuff, right? And if mp.count stuff I, so if stuff I is in here, right? Because we do -1, and enter equals max enter I minus mp stuff I, right? It's the index minus what previous index was being mapped for pref. And in the end, you return answer. Okay. So the last problem, it's Pretty nice. So it is a bitmask DP. You can see from the constraints, right? Less than or equal to 16, less than or equal to 20, usually it's bitmask DP. So problem, you have a bunch of requests that you fulfill, right? You have your number of floors, which doesn't really matter, and you have the start, right? The start thing, which one you start at. So the way I solved it was I had DP mask and I. So DP mask and I means met mask conditions at floor I. Right? Because after you finish a condition, you'll always be at the condition floors. So I just between 0 and M, right? It has to be one of 8 or 5, for example, right? After you finish any condition. And you want to move from that. So you have to fill this in first, right? Initially. So for I equals 0, I smaller than M, I plus plus. So all the requests. Now the current floor, if we start from start all the way to this floor, we have I, right? I is the only one that we met. So we have dp 2 to the I power, and then I, right? The current floor will be at I equals. So we just got to calculate the time for this. This will be the max of request I0, right? The time over here, and ABS start minus request I1. The difference between start and the floor. So for example, start equals 0 and 6, 5. You have got start equals 6 over here. This over here is 6, right? You have to wait for 6. And then the distance is 5 minus 0 is 5. So you take the max. So the time to get here would be 6. Right? The time to be able to move from here would be 6. So now you just iterate bit mask. Find mask equals 0, mask smaller than 1 to m, 2 to the m, mask plus plus. And then you look at what the current floor would be, right? What um the last floor would be at. So mask and 1 to floor. And then you take the subset of this, right? Mask XOR 1 to floor. And then you check a floor from here. You take any floor from this subset. Yeah, that works. Oh, I didn't add this check in here. I should add this and subset and 1. So this should be the same thing, right? Because if it's not and, this will just be 0. And doesn't really no, if it doesn't met, it's 1e18, so it doesn't really matter. But this is better. Yeah, this is better. So you have your floor too. So you want these floors to be not equal. They will never be equal, so that's another thing you don't need. And then you have your time is max, right? From now on, we just calculate the time needed. So what this means, floor 1, floor 2, mask, and subset, you don't have to care, right? Basically, it just means we completed subset of these requests, and now we're going from floor 2 to floor 1, so we can complete mask of these requests, right? Floor 2 has to be a subset of subset, and floor 1 has to be a subset of mask, right? Subbit has to be a bit of mask. So you calculate the current time. It should be max request floor 10, right? You still have to look at this time over here, right? You still have to look at this time over here, and it can be from dp subset of 2, right? From the time needed to, for example, reach here, plus the difference in the floors over here, right? Plus the time needed to change between these two floors. So plus ABS, all right, same thing over here. Request F2 1 minus request F1 1. And you take dp minus F1 equals the minimum of this time. In the end, you return the minimum of all dp back, or it's just meaning the array such that all the requests are met, and you take the minimum value of those. So right over here, how do we get this one? Just example, right? Over here, we can see that dp over here should be equal to 6, right? And you want to get from here to here. So you do 6 plus, but the difference over here is 8 and 5. You need 3 seconds to go from 5 to 8. So 6 plus 3 equals 9. So you need 9 seconds for over here. And you got to take the max with this time. So this time is 0. So the time needed to go here would be 9. Right? If instead we do 0 over here, so we get 8 seconds, right? And then we move over here, we do 8 plus 3 equals 11. So this DP would be 11, but we want the minimum, so we always take the minimum over here. So pretty nice bitmask DP problem. All right. So this is Leetcode weekly contest 515. Problems were pretty good except for Q3, but I probably just didn't do too well on it. But yeah. Uh, so to next week. Yeah. Okay, tomorrow I'll probably do a Repo Vibe contest. I'll see. See what contest we do tomorrow. Oh, no, there's no Repo Vibe contest tomorrow. So no contest tomorrow. Yeah. All right. I'll see y'all next time.